Look, I saw a problem in AMC 12. In one part, you should calculate something like this. So let me tell you how we can solve this. ABC squared is what?
ABC squared is S times S minus A times S minus B times S minus C.
Exactly. So if you multiply it by 16 to get rid of the denominator, 16 ABC squared is what?
A plus B plus C times B plus C minus A plus A plus C minus B plus A plus B minus C.
Okay. Then this product is what? What squared minus what squared?
B plus C squared minus A squared.
What about next one?
B plus C squared minus A squared, and this is C. Yeah, this is C squared minus A minus B squared.
Exactly. Now let's expand. 16 times area of ABC whole square is what? If you simplify, it's B squared plus C squared plus 2BC minus A squared, right?
Yeah.
What about next one?
Wait. C squared plus 2BC minus A squared, and then C squared minus A squared minus B squared plus 2AB.
So then we can say this product is what squared minus what squared?
So
Let me just check something. C squared. Here we said 2BC, right? Here we said C squared. Okay. Let me check it again. A plus B plus C minus A. A plus, oh, sorry. It is A plus B minus C, right?
Yeah.
So this one will be what squared minus what squared?
Plus B minus C. B or A squared minus B plus C squared.
Minus,
Oh, minus B minus C squared.
yeah. So if we expand this, it will be what?
If we expanded, it would be A squared minus B squared minus C squared plus 2BC.
Exactly. Then 16 area of ABC squared is what squared minus what squared?
2BC squared. So 4B squared C squared minus parentheses 8 A squared plus B squared. No, B squared plus C squared minus A squared squared.
Exactly. So look, if you have this formula, if you have a square root, we can calculate the area easily, right?
Yeah.
So memorize this. For example, here that we have root 2, root 3, root 5. Calculate the area.
So x is equal to square root of 3 over 2, or the area is square root of 3 over 2.
Square root of 3 over 2.
Yeah.
Okay, let's check. Here, for example, we can consider BCRD. So 16 area of ABC squared is equal to 4B squared. So because we have this, okay, 4B squared 3 times 5 minus A squared 2 minus 3, B squared plus C squared, which is 3 plus 5 minus A squared 2, all squared, right? 3 plus 5 is 8 minus 2 is 6. 4 times 5, 20 times 360, right? So it will be 60 minus 36, which is what?
24.
So we can cancel, we divide both sides by 8, which is 3, right?
Mm-hmm.
So you meant area is all the square roots, right?
Yeah.
Okay, yes, good. That's it's this. Okay. So it is new forms of Heron's formula when we have square roots. Let's work on the rest of this. Okay, we said all important links that we had here. Let me do something. Here, suppose that we draw external angle bisector, okay? We call it E. EB is what in terms of AB, ABC?
ED AC over B minus C.
EC is what?
BC over B minus C.
You had the same mistake for BD.
BC, it's not BC. B, AB over B
Yes, look,
minus C.
it is exactly like this. Look, A is same for both of them. Only change B, okay? EB, that is a smaller, is 8 times. C, smaller side. When E lies on left side of B, means B, this side is greater. So EC is AB, this one is AC, okay?
Okay.
And let me check. AE is what?
2BC over B minus C times sine A over 2.
Exactly. This is only for the case that B is greater than C, okay? If B is less
Okay.
than C, usually for example they write also absolute value, okay?
Okay.
Now, if you have 2 points, for example A and B, and we want to find all points that PA over PB is, for example, 2. Then, if you consider all points of P, they are what? How can we find all points of P?
PA over PB equals 2. I'm not sure.
I told you this before. Try it on your own. Also, we proved this. I remember it took around 20 minutes to prove the whole thing. Right.
I don't remember.
Okay, so let me tell you a hint here. In this
Yeah.
case, if we consider these 2 points, B and C, do you agree if we consider the distance of D from B and C, dB over this, if we consider distance of A from these 2 points is equal to, if we consider distance of E also, all of them are equal, right?
Mm-hmm.
So we can understand these 3 lines, these 3 points, green points, lie on that, right?
Lie on.
Lie on, for example, here, for example, suppose the ratio is K something, right?
Okay.
And it is a circle. And the diameter is ED because it is 90, right?
Yeah.
Okay, so here, if you want to find this, we should find 1 point inside AB, 1 point outside AB, right?
Yeah.
And then consider a circle with that diameter, right?
Mm-hmm.
So the first be PA, you should divide into 3 parts. It is the first point, right?
Yeah.
And then if you consider exactly same as, for example, it is X, it is X, it is X. If you want to consider P2, BP2 is what?
BP2 is 3x.
Exactly. Then we should consider a circle with diameter what? P1, P2, right?
Yeah,
Then all points on this circle, remember, please?
yeah.
Okay, then all points on this one satisfy that with diameter P1, P2. Okay?
Okay.
Okay. And now we call this circle what? You remember the name of this circle? What
Apollonius.
is what?
Apollonius circle.
Exactly, a Apollonius circle, right?
Yeah.
Okay. So I told you AI, I told you AIA, I told you all these things on your circle. So let me tell you, if we have this, it is A, B, C, D, E, F. AE is what?
Uh, S minus A.
Yes, let me also put a box around. Yes. Okay, so you know BD is what, CE is what, BD is what?
S minus B.
Yes, and CD is S minus C, right?
Yeah.
And we know they are equal, they are equal, they are. And if we consider this circle, ABC, if we consider this one as L, this one as N. AL is what?
AL. AL. S. Is S.
Is what?
Wait, it, it is S.
It is S.
Yeah.
PN is what?
N is S minus C.
Yes.